Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois, and this video is day 17 of the 2021 Advent of Code festivities. This is part 1, the trick shot problem, and finals have gotten to me. I'm trying to help all of my millions of students with all of their exam problems and gaming problems and all the things that I can help them with in the last day of the semester. So I'm a little behind on this, but this is a fun problem, this trick shot problem. So it starts out basically you're basically shooting a projectile, and there are some rules that you obey when it comes to drag and gravity as you're shooting the projectile out. And you're supposed to see, can I hit a target with those rules? And it's not only can you hit that target, your goal is to find the target value, or basically find the greatest height that the thing can make with any initial velocity that will hit the target. And so that's a pretty cool problem. I kind of figured where part 2 is going, but I don't want to give that away just yet for those of you. I don't want to spoil that. But for those who don't want that spoiler, but if we're kind of figuring out, like, how do I know? How do I know what is the greatest? And then the next one is like, how do I know? How do I know? That's kind of where that's going. So that's what this problem is all about. So it gives you this example with this target area here, and it says, giving this information that 7.2 will do this, 6.3 will do this, 9.0 will do this, 17.4 won't. And then what about the other one? So it says it gives you the problem here. Oops, there's my answer, 9,730. Maybe, but anyway, it says from 6.945 is the greatest that you can reach. And so the question is, what is the code that gets this? And and I just right now, like, part 1 is just a hack. Or just because I know what part 2 was, but I just don't have the time right now with everything going on to deduce how do I figure out only the trajectories to test rather than every trajectory that is possible with every integer value. Okay, so as I was saying here, with the way this is, updating on a frame, I think of it as a video game, as a frame-by-frame basis. You give me an XY and a velocity X and a velocity Y, and I will update everything. I'll update your position and your velocity and return it back to you what the next game frame should be. And so also I need to know, based on my position, am I within the target? And the one thing, you say, like, video games have taught me that versus mathematics is that when you're playing most video game systems, when you're excuse me, developing for it, that the y-axis is flipped. So normally y would be positive, and I guess in a way it kind of is positive, but we have to account for the fact that we just have to account for the fact that sometimes when things are going differently, you have to flip the y-axis. And at this point, I might have talked myself into thinking I'm flipping the y-axis when I really didn't. And in my haze, I might have done that, but I know I did have to flip these signs around. The same thing goes with the way the target data comes in, because it goes from, I think that's what it was, because it goes from low to high, but because of the y-axis, everything going down, I need to make sure that the smaller numbers on the right-hand side for the y, but the larger numbers on the right-hand side for the x. I think that's where I was going with this thing, and that's what this code does. It reads in this data, strips out all the data, doesn't matter, and it applies everything, and then flips the y so that the smaller numbers on the right. The smaller numbers on the right. So then here is my code. There's the rest of it, and again, this is the hack part for right now, is the x and y, just testing out every possible thing, 390,000 different ways of testing it out, and just saying, hey, using 0, 0 always as my starting point and these as my velocities, can I hit the target? Basically, yes or no. And like, of course I know when I hit the target, but I know when I don't hit the target, when basically I've pulled down further than the target is, because the y value is greater, then I obviously can never come back. And the same with the x, because the wind never pushes you backwards, it only pushes you so it goes straight down. So as long as basically as long as the x value is not past it on the right and the y value is not past it on the bottom, we keep testing until either we find a solution or we go and go and go and go. And it doesn't take very long. It shows me every possible, at least from 0 to 300, it shows me every possible answer. It just takes a couple seconds here to get it to a place where it can, because it's testing 90,000 of these things, and there you go. And it's going out and it goes, oh, okay, there's 9,730 ways to do it. And of course, you saw a minute ago, that is the answer. So I'm kind of curious if that's, like looking, is it the same? But anyway, I don't want to talk about it right now. But part 2, I'm going to look into that now. Next couple, think it over while I help my students. And as always, if you know a better way to do this, please let me know. If there's anything that I misspoke about or anything else, yeah, let me know. We'll fix it up. This was a fun problem. I like these kind of problems. I love the math. I love these kind of math problems, especially with video game stuff. It's like AI. Where would I need to aim to hit this moving spot or something like that? Fun stuff. Well, anyway, hope to see you guys in future videos. Hope to make future videos. Take care and see you then.